Oh hey, I didn't see you there. I was just working on some thermodynamics. Care to join me?
Sure.
Alright, well today we're talking about phase boundaries. So, if we just take a plot here, where we plot temperature on the y-axis and specific volume on the x-axis, we get a graph looking something like this. So, if we take a liquid, let's take water for example, at room temperature, so we'll start at a point right around here. And we start adding energy to the system by heating it up on a stove or something like that. We'll see that this line, the specific volume of this liquid will start to increase, and the temperature will start to increase as well until it hits a point here. We'll call this point B, which is called saturated liquid point. As we continue adding energy to this system, we'll see that the temperature no longer increases and it will stay constant. This is because all of the energy is going towards a phase change. So we'll see as we keep adding energy, the specific volume increases until the liquid is turning more and more into vapor. Then when we get to a point C over here on this side, this point is called saturated vapor. Then if we continue adding energy to the system, the temperature will continue to rise like so. This is because at this point C, we have 100% vapor. So if you continue to increase pressure, you'll see that the lines look something like this. So this first line I drew is at a pressure 1, and at an increased pressure you will require more temperature in order to boil this water. So we'll call this pressure 2. If you continue doing this, you'll start to create a curve. It'll cap off and look something like this. This curve is called the vapor dome. Welcome to the vapor dome. So if we take another plot and draw out the vapor dome, we see here there's going to be different regions. At the top here we have what's called a critical point, and we have a region to the left, middle, right, and to the top above this critical point. So this region here is called, if any point falls in this region, it's a compressed liquid. Any point that falls in this middle region is called a saturated liquid vapor. Any point that falls to the right or outside on the right side of this vapor dome is called a superheated vapor. Now, if we go above this curve, above the critical point, we have a weird phenomenon. This is called the supercritical region. And above here, there's no distinction between a liquid or a gas. Now, besides all of these regions, we can also have a point that falls along the vapor dome. So any point that falls to the left of the critical point, along this line here, is called is considered a saturated liquid. This is the saturated liquid line. Anything that falls to the right of this critical point is a saturated vapor, and obviously this is called the saturated vapor line. Well, this all makes sense to me, Mike, but I've been really having some trouble with something called quality. Could you help me out?
Sure. Speaking of quality, are you ready for a quality education?
You betcha.
Quality is a measurement of the percent vapor denoted by the symbol X. It is the mass of the vapor over the mass of the entire substance. Quality is used when a substance falls in the solid liquid vapor region, somewhere along the line here, when you don't know what percent of the substance is liquid and what percent of the substance is vapor. Quality is determined by the formula X equals beta minus beta F over beta G minus beta F.
Hey Mike, what does beta stand for?
I'm glad you asked. Beta is a generalized term used to represent a property such as H for enthalpy, S for entropy, or U for specific internal energy. Beta is the value of the property you're looking for on the line. Beta F is the value of the saturated liquid, and beta G is the value of the saturated gas. If you have the quality and you want to solve for another property, you can use the formula beta equals 1 minus the quality times beta F plus quality times beta G. Once you have a quality of the substance, you can use that to solve for other properties, such as if you have the quality of H, you can use that to solve for an S or the U of the substance.
Thanks for watching.
That was more. One more time.
More enthusiasm and a thumbs up. Thanks for watching.